Hello, pre-calculus, Math 2412 students. I'm going to talk to you about the basics of trigonometry that calculus students need. Let me just remind you that for Math 2412, it is assumed you've already had a trigonometry course. This is just a very brief review, emphasizing those facts that you need to take and use, that you'll use repeatedly in the calculus. Okay, so a good point of view to take as you approach going into calculus is to just erase whatever definition of the cosine and sine you had before and use this one, which is a version of the unit circle definition. So first of all, what's the unit circle? It's a circle of radius 1 centered at the origin, or literally it's the set of all x, y in the plane such that x squared plus y squared is equal to 1, right? You recall that as the equation of a circle. You should recall that from your college algebra course. And so if the radius is equal to 1, then r squared would be equal to 1, right? Okay, so now we overlay on that and everything you know about the plane with Cartesian coordinates, x and y coordinates, you overlay on that the definition of an angle in standard position. So our definition of an angle is that we take two rays, an initial ray that we fix along the positive x-axis. That would be here, if we're calling the origin here the point O, that would be, the initial ray is OR, okay? And a terminal ray, so the initial ray is fixed, it's always there for every angle. The terminal ray, OP, is what moves depending on, as we would say, how big theta is, right? So what is OP theta? Well, P sub theta, by definition, is the intersection of the terminal ray of the angle with the unit circle. Okay, so P sub theta is always a point on the unit circle, some x and y, such that x squared plus y squared is equal to 1, okay? As you can see right here, if theta was equal to 0, then we would have x squared plus y squared equal to 1 in the form of 1 squared plus 0 squared is equal to 1, right? All right, now here comes your definition, moving forward, of what the cosine and the sine actually are. So you just want to forget about SOHCAHTOA or whatever way you memorized it before. Memorizing 500 facts as you go into the calculus is not a good idea, all right? So you need to have this more easy to rederive from definition, okay? We're going to define, since every point P sub theta has an x coordinate and a y coordinate, which you can see as theta grows here, that x and y coordinate of that point is definitely going to change. So each of those are functions of theta. We're going to assume that the cosine of theta is what we just call the x-coordinate of P sub theta, where theta is in standard position and the terminal ray of that angle is intercepting the unit circle. We are going to define sine of theta as being just the y-coordinate of that P sub theta. Notice that that gives us right away a number one identity you're going to use over and over again when you're in the calculus, that since x squared plus y squared is equal to 1, and now the x coordinate is just cosine of theta and the y coordinate is just sine of theta, we now have that cosine squared of theta plus the sine squared of theta is equal to 1, period, for all angles theta. So right off the bat, we get the first identity, which you will use over and over again in the calculus. Secondly, it's really easy to compute the cosine and the sine using this definition of it, no matter what size the angle is, whether it's positive, negative, whatever quadrant it falls, P sub theta falls in, it's going to be easy for us to derive what the x and y coordinates of that point are and come up, therefore, with a cosine and sine. So you should practice this kind of thing. Throw down some angles. Oh yeah, you'll notice that I'm constantly referring to angles in radians. And you need to do that as well. The calculus is beautiful if the angles are in radians. The calculus is really ugly if your angles are in degrees. So as you move into calculus, and in this pre-calculus class, we're going to try to keep our angles in radians all the time, as much as possible. So for example, if the angle is 0, there is p sub 0, it's the point 1, 0. So what's the cosine? What's the sine of 0? If the angle is 0, the cosine is, just read it off of the coordinates, 1. What's the sine? 0, because those are 2 coordinates. Same thing with pi over 2, also known as the 90-degree angle. There is p sub pi over 2 on the terminal ray. It's at the point 0, 1. So the cosine of pi over 2 is 0, the sine is 1. You should build yourself a table like this. Just grab some paper and a pen and just throw down some angles in radians and ask yourself, what are the cosines and sines? Be able to whip those out just from drawing the angle in standard position, okay? These angles, pi over 2, 2 of the pi over 2 gives you a pi, right? You want to learn to count in multiples of well-known fractions of pi. 2 of these pi over 2s gives you 1 pi, right? P sub pi is over there, p sub pi. And its coordinates are -1, 0, so therefore the cosine of pi is a -1, the sine of pi is 0, and so on. 1 pi over 2, 2 pi over 2, 3 pi over 2. Get used to counting them and seeing how they're related. You fill in the blanks here. Next video, I'll pick up with the topic, what do you do when theta is not one of these quadrantal angles?